permutations. So like as a more like concrete example, let's say you have I don't know, like seven objects, like seven objects, we'll say, and then you want to choose like, and they're all like different. All the objects are like distinct, and we wanted to like arrange three of these objects in a line or something. Like so, like we want to arrange um three objects in a line. And let's say we wanted to know how many ways there are to do this. So this would be like very similar to the factorial thing that we just talked about, like about the people standing in a line. So if we want three objects, and we have seven objects in total to choose from, then this first position, like for the object first in line, there are seven ways to choose what object goes first, right? So so let's say you choose like one object. Now, once you choose that object, like the second object here, you have six ways to choose what object to go there because you already used up one object, so you can't use it again. Like you already used one object for the first position, so you can't use it again for the second position, which means you only have six choices left. And then after you choose the first and the second objects, then you have five ways to choose what like object goes in the third position. So you would just get 7 times 6 times 5. So that would just equal 210. So this kind of is like a generalization of the people standing in a line problem, except this time we don't have to use all seven objects. Like this time it's not 7 factorial, like because we only want to choose like a subset of these objects to arrange in a line. So now let's like consider a more general case. So let's say we had like n objects and we want to arrange like k of these objects in a line. So instead of 7 and 3, which is the numbers we just used, now we're going to use n and k for the objects, for the numbers. Okay, so then now how would we do this? Well, basically this would be the exact same like way that we just did the case for 7 and 3, 7 objects, and we want to choose 3. So again, we want to arrange k of these objects in a line. So 1, 2, 3, like let's say we have k of these blanks, and we have n objects in total. So we can use the same like logic, I guess. In the first spot, we have n objects to choose from. So like there are n ways to choose what object goes in that first spot. Now, once you choose that first object, the second object, you have n minus 1 ways to choose what goes there. Because you can't choose the same object as the first one. Now, the third object, you have like n minus 2 ways, because you can choose anything except the first and second object. So there are n minus 2 ways to pick what goes in the third object, third spot. And we can continue this process until we go all the way until like the end, where we have n minus k plus 1 ways to choose like what goes in the last spot. And let me just in case like this plus 1 thing is not like entirely clear, why do we have to do a plus 1? Like you can think about it as like we can write this n as n minus 0. So like and this is for the first position, and we're doing n minus 0. This is for the second position, we're doing n minus 1. This is for the third position, and we're doing n minus 2. So like if we're doing the kth position, this is going to be the kth position, then we would want to do like n minus like k minus 1, which is the same as this. So hopefully that made sense, like why it's going to be n minus k plus 1 as opposed to something like n minus k or something. Yeah, it's very important to be like careful about these like edge cases kind of. So this is how like we would arrange these. And now to find like your answer, we would just multiply all of these. So n times n minus 1 times n minus 2 times ... times all the way up to n minus k plus 1. But like we can like kind of make this expression a little cleaner by noticing that we can kind of multiply this expression by, if we were to multiply this by n minus k factorial divided by n minus k factorial. Like I'm not doing anything, right? Like essentially I'm just multiplying top and bottom by 1. I'm just multiplying by n minus k factorial over n minus k factorial. That's just 1, so I'm not really doing anything. But like, I'm just going to do this because like it's going to make the form nicer. And the reason is because now if you look at the top, so if you just look at like this top here, n minus k equals like n minus k factorial equals n minus k times n minus k minus 1 times n minus k minus 2 times dot 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 times 2 times 1. So this entire expression here, this entire expression, that just equals n factorial when you like combine like these terms together as well. And then the denominator here, you have just n minus k factorial. So this represents the number of ways to like kind of permute k objects from a total of n. And sometimes you might see like the mathematical notation like NPR or NPK, like you might sometimes see that to represent like the number of ways to like arrange k objects in a line from a total of n objects. There are probably like other notations, but like usually you won't have to worry about like the notation stuff as long as you know how to like use it and understand it, and you understand how it works, and like it's fine.